All right, guys, welcome to this week's lab. And this week we are looking at air masses and weather maps. So what you will be essentially be looking at are mainly like cold fronts, warm fronts, and just pretty much how to like their labels on maps and how they form, and mainly different air masses that are involved with these. So what an air mass is defined as is a large volume of air that's in the atmosphere, and it's uniform in terms of temperature and moisture. And what that means is if it's warm, it's usually all warm, or if it's cold, it's usually all cold. And moisture, if it's dry air, or if it's moist air, it's whatever it is, it's usually uniform. So the whole air mass is either moist or dry. It's either Usually the whole air mass is either warm or cold. Um, and so that's mainly what that means is it's just a mass of air, uniform temperature, uniform moisture content. And so the four types of air masses we're looking at for the sake of this lab is maritime polar, which is MP, maritime tropical, which is MT, continental polar, which is CP, and continental tropical, which is CT. And there are a few others outside of these four, but these are just the main four we're looking at. And mainly the polar and the tropical, more or less, that's just kind of showing like where it is in terms of in relevation, like in relevance on the Earth, in terms relevance to the equator. And I'll get more into that in a little. So we'll start with maritime polar. And so what that is, it forms over the Atlantic because it's maritime or marine. That's where the name comes from, maritime. So it forms over marine-like water or oceanic water, if you will. And so it usually does originate directly over water, in this case in the northern Atlantic, and that's where the polar comes in. So maritime polar. So maritime means marine or oceanic, and then polar is near the poles, so north or south. In this case, you're looking at a more northern maritime polar air mass, and that's pretty much how they're named. And so what these have the precipitation for this is lighter. It causes more drizzle or light rain or rain shower. And it does have influence on other air masses near the coastline. And what they can do, like you can see here, is they can start over land and then kind of move over to a body of water. In this case, do the opposite, but they can start over land and then move over to a body of water to kind of reach that cool, moist climate that maritime polar air masses are defined by. So this is just kind of a visual example of the maritime polar air mass on a map. Next is maritime tropical. And then again, just kind of like maritime polar, it was near the pole. In this case, you're looking at, okay, maritime, it's an air mass over the marine, over ocean. Now this is tropical. This is much more near the equator. And in this case, it's right here. It's right by Florida and Cuba and Puerto Rico, and it's right by the Caribbean. And these, as you can imagine, are very warm, very humid weather, and so these are very warm, moist, humid air masses these are maritime tropical. They form on the ocean near the equator, near the tropics, so tropical. And that's how that's how these air masses are named, pretty much based off where they're located. In this case, it's maritime over the ocean, it's tropical near the tropics, near the equator. So you're going to have very warm, a very moist air mass. So that's what a maritime tropical and MT air mass is. Next is continental polar. I don't know why this image came so blurry, but and now what this is, as opposed to maritime, you have continental polar, and now that's the similar air mass. Now it's just over a continent, continental. It's over land. and it's polar, so it's near the pole. It's more northern. It's going to be near, as it says, develop over land masses over subpolar regions. And so, like, also like this says, it's of areas of higher altitude. So like this picture has Canada, the northern US, northern Asia. And so that's where you're going to find these air masses, continental, polar, over the continent near the poles. And kind of like the weather at these places, you have cold, dry weather. Not a lot of clouds, not a lot of rain, not a lot of precipitation. And so that's kind of how you can, in a way, that's kind of how you can memorize what weather is associated with these. Just kind of think of the name. So you have a continental polar air mass. Well, okay, let's see, you're going to be over land, you're going to be much more northern. So you're going to have dry and cold air. And that's how these, pretty much where these air masses are located is pretty reflective of what their climates are, like what their composition is. In the case of the continental polar, in the case of continental polar, it's cold, it's dry, very little precipitation, very little rain. And so that's, again, how you could kind of memorize these air masses. And the last one of the four we're looking at is the continental tropical. So before we had the continental polar, and like this one, continental tropical, again, it's going to be over land because it's continental. And it's going to be near the equator because it's tropical. So you remember maritime tropical, right? It was right by the equator, right by the tropics, but over water. Now you have continental tropical. Same thing, same concept. This time it's just over land. And it's the area that's just 25 degrees north or 25 degrees south of the equator. And now the difference between the continental tropical and the maritime tropical is the continental tropical air masses. They primarily occur over desert-like areas. So they occur over the Sahara deserts, the dry parts of Mexico, dry parts of Australia, the Arab Peninsula. And these air masses are associated with drier climates, they leave a drier effect. They're associated with droughts, and they do leave, and they can cause severe droughts in the regions that they're present, like the Sahara, like the deserts of Mexico, and so things like that. So that's kind of the difference between the continental tropical and the maritime tropical. The maritime tropical, you have much more moisture because you're over water. You still have that heat, you still have that humidity, but you're over water. With the continental tropical, you still have the heat, but you don't really have the humidity because you're over land. And so that's what leads to hot and dry climate, is continental tropical air masses. So yeah. So those are the air masses. Those are the main four. I'll come back to them again after I finish the PowerPoint, but those are the main four air masses that you're going to utilize in this assignment. So next up is cold front versus warm front. So we'll start with cold front. And how a cold front works is the cold air moves into a warm air. So the cold air moves into warm. And that's kind of how you can try to memorize these: is a cold front, the cold moves into warm. A warm front, a warm moves into cold. But we'll look into the cold front first. So for a cold front, cold air moves into a warm air mass and pretty much pushes it up. And that's how you get a cold front. Because the resulting air that's pushed downward, essentially, towards the Earth's crust, towards the land, that's the cold air. And that's how you get a cold front, because that's what's being pressed towards the land. So for a cold front, the cold air moves in. And what these produce is, cold fronts produce more gusts, sudden drop in temperature, heavy rain, sometimes hail, and lightning. Cold fronts produce lightning more so than warm fronts. So that's just make sure to note that. And how cold fronts are identified on a map are these blue teeth-like triangles. So that whenever you see these on a map, instant cold front. That's what that is. It's a cold front moving in. You'll see them on weather channels. If you get a chance, you should try to watch the weather. Although Fresno doesn't get a lot of cold fronts, but still, it's still interesting to watch the weather. And you'll always see, whenever you see a cold front, it's going to be these blue teeth here at the bottom. And another note, blue fronts or cold fronts are what cause light. Now, next up is a warm front. So kind of how the cold front moved into warm air. For a warm front, warm air moves into a cold air mass. So that's a good way to memorize it is cold front, the cold moves in, the warm front, the warm moves in. The warm moves into a cold air mass and essentially covers it. And warm fronts are known for bringing stormy weather. When they come in and they're pretty much kind of thrust on top of cold air masses. That's kind of how, that kind of creates a storm-like effect, and that can create stormy weather. And so these all are characterized by red semicircles. So they're kind of the opposite of what the blue triangles of what cold fronts are labeled as. Warm fronts are labeled by just these red half circles that are on a line and they move in. Now, you'll see a lot of these in Fresno. Well, actually, I take that back because there's not a lot of cold air. You won't see any fronts, but yeah. So warm front. Long story short, a warm front is when warm air moves into cold, and then a cold front is when cold air moves into warm. And the reason why warm air is always ends up on top, the cold air usually always ends up on bottom, is because cold air is heavier than warm air. I don't know if you ever heard the term heat rises and cold sinks. That's kind of what's happening here is, even though warm air moves into the cold, it still ends up on top because the cold air is just heavier. So yeah. And now the last part is going to be hurricanes and tornadoes. You do have a few questions on these, so I just want to make sure to cover them. And so we'll start with hurricanes. And now, so how hurricanes work is there are these large storms that kind of rotate with the spin of the earth, and they usually occur over warm water, which is usually in tropical areas. So what they are is, yeah, they're large rotating storms with high speed that form over warm waters in tropical areas. And so they usually form over the tropics, which is, again, where the maritime tropical air masses are. So that's usually the air that serves as the basis from where hurricanes form. And how they form is warm air over the moist air over the warm water rises. It gets replaced by cooler air. And then the warm air keeps rising, and that forms storm clouds. And this is kind of like an ongoing process. It is a good way to think about it. Now, once these storm clouds start rotating, so before we get there, at first you're just forming storm clouds. You're just getting that warm ocean water rising out of the warm tropics, and then the cooler air is coming in to replace it. But this keeps going. You keep having this process. Eventually, these clouds are going to begin to rotate with the spin of the earth, which we kind of talked about. And so it's when these clouds start rotating is when you start seeing this image here. This is a full-on hurricane, but that's when you start seeing a tropical storm, which is what precedes a hurricane. Once storm clouds begin to rotate the spin of the earth, they'll start forming this organized system. They'll start forming this kind of cyclone-looking cloud. And then if it's still over that warm water, if it's still in the warm tropical water, the cycle continues. Warm air keeps evaporating up, getting replaced by cool air. And these clouds keep forming and then keep spinning. Once this keeps growing, wind speeds start to grow as well. And that's what forms a hurricane. This is just constant cycle warm air rising, warm, moist air rising over the water, over the warm water, getting replaced by cool air, and forming these storm clouds. They keep forming and forming and forming, and then once they start going with the spinning with the spin of the Earth, they start rotating with the spin of the Earth. That's how you get that cyclone look, and then that's how hurricanes start to form. And the reason they're so deadly is because they're a collection of storm clouds, if you will. Just think of this, all these clouds, they're a collection of storm clouds. And so you get that wind, you get that rain, you get all this, you get lightning sometimes. So you get all these elements kind of working as one, and then that's what makes hurricanes so deadly. Is you just have this giant collection of storm clouds it's rotating with the spin of the Earth, and now it has these high wind speeds as well. So wherever it goes, it's just going to lead destruction, and they can cause a lot of damage. They have caused a lot of damage and death in some cases. So that's just more or less how hurricanes form. Although in Fresno, you'll probably never see one, but that's how they form. Now, next up are tornadoes. Now, tornadoes are different from hurricanes because they don't need moist air. They don't need that tropical, humid, warm air, moist air to form. That's not how they form. And what tornadoes are is they're just it's a rotating column of air that extends from the base of a thunderstorm down to the ground. And it's once they touch the ground that they're considered a tornado. And they are very deadly, though, once they do touch ground, because they can tear apart houses, farms, they can lift up cars, anything once they form. Hopefully none of you guys have been in a hurricane or tornado. But if you have, I'm very sorry for you, but you've probably seen the destruction they bring. And how they form is tornadoes form when warm air collides with cold air, cold and dry air. And so what happens is the cold air, since it is denser, it's pushed over the warm air, and that's what produces the thunderstorm. And then that change in wind direction and the change in wind speed is kind of what causes that swirl. And so once the rising air from the ground kind of pushes up on the swirl and tips it over, that's how you get that funnel. And then once the funnel once the warm air keeps getting sucked up, and then once that funnel kind of touches the ground, that's when the tornado forms. So here, this picture, I tried to put in again, and didn't come out perfectly, but you have the cold air coming down, the hot air coming up. Long story short, and that ends up causing a kind of this difference here, this rotating column of air. It's just where this cold and warm air meet, this cold and hot air meet. And it's usually caused in a thunderstorm. And so it's just, you keep getting that rising hot air pushing up against that falling cold air. That difference is what causes the tornado. It's pretty much just differences in air, two different airs pretty much colliding. And that's what's giving you that tornado-like effect, if that makes sense. So that's pretty much it for the PowerPoint. Now the lab for this week is pretty straightforward. You're just, again, filling in the map. Again, you're only going to have 4 options for the air masses. You're going to characterize the air masses. There is a few kind of geographic questions as into locations. Worst case, you just look up where the Rocky Mountains are if you don't know. Look at the Northwest Pacific Coast if you don't know. So once you fill in this map, the rest of the question should be relatively straightforward, revolving around that. And then next, you're going to start answering questions about fronts. Again, hopefully that's answered for you in the PowerPoint. And then question 7, try to think more in terms of just the air, the type of air that's being involved. Same with question 10, I believe. And then the last thing for question 11, the difference between, so for question 11, so the difference between a tornado watch and a tornado warning is when is pretty much tornado presence. So a tornado watch is pretty much that all the elements are there. Right now, this is the perfect environment for a tornado. So when you see a tornado watch, that's saying that, okay, there's a cold and a hot air front, if you will, in the area. So pretty much all the elements are there for a tornado, but a tornado hasn't formed yet. So they're watching for one. So that's a tornado watch. A tornado warning is usually a tornado has been spotted. A tornado either is going on or it has been spotted. So that's the main difference between a tornado watch and tornado warning. So yeah, a tornado watch is all the elements are there, but it hasn't been spotted yet. Tornado warning, a tornado has been spotted. And so that's the main difference for that. But yeah, so yeah, that's pretty much it. Again, if you have any questions, please reach out through email or Canvas. And yeah, I hope you guys have a great week.